Hi, Abino. Are you there?
Sir.
Hello. Hi, Abino.
Yes, sir. Am I audible?
Yes, you are. Is this already live on YouTube?
Yes, sir. It started.
But why it's only why it's only 5:30? It's too early.
No, sir. We are just putting in as it will be updated in the page by that time.
So I think okay. So all okay, right? All is in
Yes,
place.
sir.
Huh?
Yes, sir. Yes.
So you will do the introduction, or Sudha will
Yes,
do?
sir. So I'll be doing it.
Okay, fine. And your connection is okay today?
Yeah. Yes, sir.
Sometimes you're having a problem, right?
Yes, sir. So that is there for backup if anything goes wrong. But,
What's happening? You have a problem where you are, or is it something else?
no, sir. Actually, on Teachers' Day, I had consumed all the data. So.
Okay. All right. And yeah, I just had a chat with him.
Yes, sir.
He called me some time back. So he was. So he might want to actually also keep looking at the chat and respond even when he's speaking.
Okay.
He may not do a full talk and then take interaction. So we'll let him decide what he wants to do. And I told him that we have our student coordinators who will actually do the moderating. So you can,
yes,
between you and Sudha, you can figure out what works best.
Yes, sir.
Okay. See you. Okay. Thanks.
हाँ अभिनव
हाँ
वेबसाइट पे डाल दिया, चेक कर। मैं चैट पे डाल रहा हूँ, यहीं से डायरेक्ट विजिट करके देख ले। ये लाइव लिंक है, उस पे कोई भी क्लिक करेगा तो वो डायरेक्ट यूट्यूब पे चला जाएगा।
Hi, Priya.
Hi, Pankaj.
Hi. No, I just wanted, he just called me 10 minutes back. We had a brief chat.
Okay.
He was
Okay.
for some background and he wanted to know whether the students have a biology background. I said, no, they're all very far away from biology.
Yeah.
So he wants to do a little bit more interactive. So I said, yeah, you can take a call. You do as you feel appropriate.
Yeah,
so,
that's great, actually. Yeah.
So let's see. He said he's looking forward. So I just thought.
Okay, nice.
And I also told him that he can, I mean, the chat is there and students could help him moderate and all that. He said, that's fine. He'll keep looking at the chat and he will also, we can see how it works out with the TAs and him.
Yeah, super. Good.
Okay.
He seems like a very experienced person, so I'm sure he'll be able to manage quite well.
He was just telling you, they've been doing these rural trainings for youth to deal with COVID.
Oh, yeah?
He said he'll talk about that as well. And if he does not, we should remind him. He says
Yeah.
of 25, all Ichalkaranji, Satara, because he's part of that, Pune district COVID task force.
Okay, very interesting.
He has been training, I mean, going about, so I mean, he has very, very, very interesting experiences he has. So
that's great.
Yeah, great. Okay, lovely.
That's great. Yeah. So I think that'll be good, actually, if he talks more about his management and
also, yes,
how he's been managing the COVID thing. Yeah.
Yes. Let's see. I mean, I told him that he should talk about, I mean, because of the rural dimension for Sitara.
Yeah. Right. And even urban, the management part would be more interesting than.
Sure.
Yeah.
So, I mean, yeah, let's see what he does.
Yeah. Okay.
Okay.
Hello, Pankaj sir and PMM. Please, could you help me in doing one thing? I have posted a link on the chat. Please, could you check if in that link the YouTube video is showing or not at the bottom?
Sure. I'll check. Oh. No.
Again, that problem. It is showing for me and not showing for others. Then, okay, I will check with Vishnu right now.
But Amol, which link? There's a YouTube link and there's a Sitara link. Which one are you talking about?
Sir, the link I just posted in that link.
In the chat. No, he's talking about the link in the chat.
No, there's one link that is also there for YouTube link.
No, not in the chat. That's outside.
No, it's in the chat also. But you're talking about the Sitara link.
Yes, sir. Sitara link. There should be a live video over there.
I see only. That's funny because I see only 2 Sitara links.
No, you may have. It was. I think it was there before you joined. So maybe that's.
Oh, I see. Okay.
Yeah. So on the home page of Sitara, there is no link, no video.
Sir, on the home page, after you go in the home page, on the right side there is seminar section. In that section, there is an option for this seminar on the top.
No, this link goes straight to the home page with the abstract of this talk.
So in that at the bottom there should be a video. For me, it's showing. I just posted the video, but for others it is not showing. I'm not sure why.
It's not showing. It's not showing.
Yeah. Okay. I'm checking.
This is the home page with his details.
Yes, sir.
It is showing the details of the speaker. And
so right. So that is the page with the seminar details. And I think Amog is added the YouTube link at the back, but there's something wrong with the refreshing of the page or something. So it's not showing up for us.
Oh. Yeah, usually it takes some time, but it's 10 minutes already.
Yeah, but that day Amog, it just for several hours it wasn't there.
Yeah.
So is it?
I think there has to.
Is it 5:30 or is it 5? Is it about the time? No.
No. It's nothing like that. It's just the link. I think it's okay. Anyway, nobody is going to find the link on that page really now.
No,
I mean, the people.
There are a couple of people who send the link to.
Yeah, that will work fine. Pankaj, that will work fine. This is only a link on our Sitara website to that YouTube, but that's okay. I mean, nobody is going to go to the Sitara website and look for that link.
No, the thing is that the announcement has that link in case it goes.
No, but it has a YouTube link also, right, Amog?
Yeah.
That's true. Yeah, okay.
So they'll go to the YouTube link. It's more likely they'll go to the YouTube link rather than.
Yeah, but if you can set it right, it will be. I mean.
Yeah. I will. I'm updating it so that it can be. In the email there was no YouTube link because while we can make the YouTube link only when we start the webinar. So that is the problem. That's why I just updated the YouTube link.
Oh, I see. Okay.
So, otherwise, the YouTube link could have been before also. So the stream has started just now. So that's why the YouTube link is made.
And your class is joining, no? Amog, Abhino?
They better. They all have to.
I know, that's what I'm saying. They should. Tomorrow great penalty hoga, Amog.
Yes, sir. I am asking them to join.
Please inform us. It's 5:25.
That's Bino and Sudha. They are the TAs for seminars. So, unke great penalties honge.
No, please inform because it's 5:25. We should not be here after the speaker comes. Please just inform your class.
Yes, sir.
That's correct. It's already 5:22. They better be here.
I'll remind him also.
No, don't remind him. It's okay. Let him come. Otherwise, he'll come on time and people will be still like strolling in. So. I think we should tell them though, because I'll send an announcement to everyone, because even last time they came in a few minutes late. Hey, Pankaj.
Yeah.
I think you better remind the speaker.
Yeah.
Does he have a? I asked him if he has a presentation. I don't know if he has one or if he's just going to talk.
He will have a PPT. I'll just call him.
Okay, then he needs to. Yeah. So let's just.
He's not joined yet, no? Yeah. Good evening, Shiva.
Dr. Shivakumar, hi.
Hi.
Can you the background is very late, so is it possible? We can't see your face actually.
Okay, so I'll change my position a bit.
Please.
This is better?
Yeah, this is great. Okay.
Yeah, this is great. Welcome.
Welcome.
I'm Priya Jadhavi, correspondent.
Yes.
So, do you have a presentation, Dr. Shivakumar, or are you just going to be
Yes,
talking?
I do, but it's not a very well-prepared presentation.
No,
So
that's
I'm
okay.
going to go back and forth a bit.
Sure.
I will be-
As you wish. Yeah,
Yeah.
that's great.
So
Anyway, we are all looking forward to the talk.
I can share my presentation. I can. Can
Yeah,
I?
whenever you feel. Yeah, please.
Yeah, sure. Do you want to introduce me first, or?
Yes, we do. Yeah, I think we should start. So, Sudha or Abhino, you all want to go ahead?
Yes, ma'am.
Yeah. please
Am I audible?
Yes, you're audible.
Okay. So, hello everyone. Welcome to the Sitara seminar series. Today among us, we have Dr. Shivakumar Iyer. He is a medical professional for over 30 years with expertise in critical and end-life care. He has been president of Indian Society of Critical Care Medicine and is currently professor and head Department of Critical Care Medicine at the Bharati Vidyapeeth Hospital in Pune, which is operating an over 300 bed facility for Corona. He is also a member of the Pune District COVID-19 Task Force. He is currently also doing an MSc in palliative medicine as a Commonwealth Scholar at Cardiff University. On behalf of the Sitara family, I welcome you, sir. And now we can proceed with the session.
Good evening, everybody. My special thanks to Pankaj, who's been my friend for a long time. You know, from the time I joined medical school, and we've, you know, even though our friendship has been punctuated by absences, we've always maintained this thread, which has helped sustain this friendship for such a long time. So I'm hoping that you all will also be friends. And, you know, in a sense, this talk is going to be like a conversation that I'm having with you. Like, you know, I have had so many conversations with Pankaj, and the conversation, you know, it will have me speaking for a while. And then if I pause and if someone feels that there is some pressing question you would like to answer, you can raise your hand, or you can interrupt me, and then we can take that question and we can go ahead. You know, Pankaj was a bit concerned that, you know, the talk may get derailed, or I may not be able to cover all the points that I hope to cover. But I think I'll be able to get back the focus. And we do have a fair amount of time. That's what Pankaj just told me. We can go on
Definitely.
for 1.5 hours. And so what I will do is I will start with what I propose to talk about. And in a sense, you've already got that thing that I sent you, the short synopsis of what I hope to cover. I think it was very ambitious. And in the last 3-4 days, I have been so swamped by work. I've not had time really to work and prepare a polished presentation. But I think in a sense that is good, because when things are unfinished, we can have you know, new directions through that. So I'm going to share my PowerPoint. So, you know, a 360-degree view is a difficult task, because our vision in a sense is, you know, only in the front direction. And really to get a 360-degree view of anything is a difficult task. The COVID-19 is, of course, a viral illness, the latest pandemic that has, you know, affected all of us in ways that are going to change our world completely. So I'm going to speak a little bit about viruses and bacteria, then a little bit about the history of our world, and there may be some of you who are who know more about this evolution and maybe more about how the Earth has evolved than me. And if you have any comments or ideas to offer, I would be more than willing to listen. So I'm going to talk about how life on Earth has evolved, and where are viruses, bacteria, where are we, and how are we interconnected. And this interconnection has been explored in ways in the last 2 or 3 decades that have completely changed how we look at evolution. So if we think of evolution, the name that comes to mind is generally Darwin. But in the 20th century, and now in the 21st century, a new branch of science has evolved called evolutionary biology. And this evolutionary biology has been based on the rapid advances that have occurred in genetics and in the way we are able to, access and identify small pieces of RNA, small pieces of DNA. And this, in a sense, has helped us to map not just our human genome. You must have all heard of the Human Genome Project. So the human genome is entirely mapped. It has led to what has been called a bacterial genome project. And what we knew for a while was that in our body, we do have many bacteria living within us, but we did not know the extent of these bacteria. And these bacteria we could not study. But now, with the evolution of this technology that allows us to study RNA and DNA, it's called PCR technology, polymerase chain reaction. And I'm sure you must have heard of the RT-PCR test, which is done for the coronavirus. So this PCR technology has meant that we've been able to really map quite a few bacteria. And what we've realized is that within the human body, the number of bacteria exceed the number of cells, by an order of magnitude of 3. So there are 10 raised to 3 bacteria in our body. And not to speak of viruses, the viruses are an unexplored dimension. We are still only beginning to explore the diversity of viruses, just beginning to realize the biological diversity. And Pankaj has worked a lot on biological diversity in places like the Andaman, where the gross biological diversity has been studied. And of course, Darwin and evolution was about gross biological diversity. When we look at the biological diversity in the microscopic world, that is bacteria and viruses, those are fields that are just going to be explored. So much so that a person called Carl Woese, who's widely regarded as the father of evolutionary biology, he said that if the 20th century was the century of physics, then the 21st century is going to be the century of evolutionary biology, and it is going to affect and unite the physical, biological sciences in ways that we are just about beginning to comprehend. So this figure, I'm not sure whether you're able to see the figure. I'm just thinking whether, so you can see to increase the size of this. I hope it's more visible now. So, if we were to compress the history of life on Earth into a calendar year, you can see that viruses came on the scene somewhere in the early part of March. at this point. Yeah, and these fossil bacteria and the others, they came at that time. And they've been there from March till December or so. And you can see that man really has come in the last 30 minutes or so before midnight on 31st of December. So the bacteria, viruses, they've been there for so long before us that it is really amazing that we did not know of this before. And of course, evolution, I'm not going to go into those details, but you can see evolution from unicellular to multicellular organisms to the dinosaurs, then that became extinct, then the reptiles, and then the mammals, birds, the flowering plants, which were also quite a late addition, and then of course humans. So this history of life on Earth, if you were to compress it into a calendar year, man has been around only for 30 minutes in the last hour before midnight on 31st of December. And what this essentially means is that bacteria have been there for a long time. And in the words of Stephen Jay Gould, they are ubiquitous and indestructible. The number of E. coli, which is one of the bacteria which is present normally in our gut, in the microbiome in our body, it far exceeds the number of people that now live or have ever inhabited Earth. So not only is there great diversity, the number of bacteria exceed the number of cells, they also exceed the number of people that have now lived or have ever inhabited the Earth. So you can see that bacteria have been there for a long, long time. And similar is the case with viruses. So, I mean, if we think that without viruses or without bacteria, we can live or continue to exist, that is not possible. It's simply not possible. So then how do we coexist? We coexist in this wonderful symbiosis in our human body. So this symbiosis exists at a microscopic level as well. And this is something which we would well do to keep in mind as we go ahead in this presentation. The next slide that I'm going to show you is Carl Voss's contribution to evolutionary biology. And if you see that previously there were only two families described, or two domains of families described, which were the bacteria and the eukaryotes. Okay, and a third domain of life was described as archaea, which include the extreme halophiles, thermophiles, which are known to exist, at the edge of, literally at the extremes of temperature. So minus 100 degrees or very hot 200 degrees. So both extreme halophiles and so thermophiles on both sides were known to exist. And of course, in eukaryotes, you can see that the kingdom Animalia, fungi, plantae, ciliates, flagellates, microsporidia, all those families come in from the unicellular to the multicellular to plants, animals, and fungi. And you can see that the single stem below is described as the last universal common ancestor. So this last universal common ancestor was a cell which is the grandfather figure for bacteria, for archaea, and for eukaryotes, for all plants, animals, bacteria. And so we are tied together in this in such a way that we cannot break free of our ancestry. And before the last universal common ancestor, probably, was a world called the RNA world. And this RNA world was inhabited by single-stranded, double-stranded RNA. And at that time, the RNA molecules, they began to self-replicate. And then, of course, there are many theories which describe how RNA may have given rise to DNA and how life further may have evolved. So this then is going to be the science of this century, evolutionary biology. And so if, all of you all are now students doing your MScs, but maybe your children or younger people will probably choose evolutionary biology as one of the most exciting fields that exist. Now, coming to the SARS CoV2 virus. So the SARS CoV2 virus, as the name stands, it's severe acute respiratory syndrome coronavirus 2. That's the name of the virus. It's a single-stranded RNA virus. So RNA stands for ribonucleic acid, and it is one of the building blocks of protein. And like DNA, which can replicate, RNA also is known to replicate, and it is an essential part of protein synthesis. So viruses can be both RNA viruses and DNA viruses. And viruses have been described as being at the edge of life, because on their own, they do not exhibit any sign of life. But the moment they come into contact with living beings, and this may be right from unicellular organisms like bacteria to completely complex multicellular organisms who regard themselves at the peak of the evolutionary ladder, like human beings. When they come into contact with them, that is the time when they can enter these cells of these organisms and use the cellular machinery to replicate and create small copies of themselves. And once they create these small copies of themselves, they can go out of those cells and give rise to infections. The human genome also has these small strands of RNA or DNA, which may represent viruses which have been incorporated into the human genome many, many billions of years back. And so in many ways, the humans are not in that sense living in a vacuum. We are connected in many, many, many ways. So the SARS CoV2 virus, like I told you, is an RNA virus. It belongs to a group of viruses called the coronaviruses. And there are many coronaviruses in nature. Humans are affected by 7 types of coronaviruses that have been identified so far. 4 of these cause only mild upper respiratory infections and are responsible for about 30% of the upper respiratory infections that we may get seasonally. The 3 coronaviruses that may cause severe illness, like the severe acute respiratory illness, are the SARS CoV1, which was first described in 2003 when it caused an epidemic of frightening proportions, not because of the number of people it affected, but because of the high mortality that it was associated with. So this SARS in 2003 had a mortality in the range of about 10%. So 8,000 people approximately were affected and about 774 people died. And that's a very large number because usually mortality due to viruses, if we take the influenza virus, for example, is 0.05% or 0.1%, in that range. And even the mortality related to COVID-19, though you may hear different mortality rates being described, is expected to be below 1%. So that was the SARS CoV1. Then there was a second virus which came about 2010 or so, called the MERS, or the Middle East Respiratory Syndrome virus. So this was also a coronavirus, but it did not bear very close resemblance to this SARS CoV1. And then, of course, the SARS CoV2, which was christened as such in January 2020 by the WHO. It was also called the Wuhan virus or the China virus, and famously by Trump, trying to. So what the WHO felt is that it should not have any geographical or ethnic tone to it, and therefore it was rechristened as the SARS CoV2 virus. Just to describe the virus a little bit, viruses generally have, they have an external capsule, and the capsule may have spikes of this kind, these red dots that you see. red structures that you see on the surface, they are called spikes. And the spike protein is the protein that attaches itself to human cells. And then they have a capsule or an envelope. Within, they have a membrane. And within that, they have the nucleic acid, which is the RNA. Now, how do these viruses enter? So this figure depicts that. I'm sure you don't need to understand the details of this diagram, but if you see on the top of the diagram, you can see on the left upper hand corner, you can see the SARS CoV2 virus. And the SARS CoV2 virus, when it comes in contact with usually the nasal epithelial cells, the predominant mode of spread is through coughing, sneezing, speaking, through droplet infection. And so when it comes in contact with the nasal epithelial cells, you can see that the spike protein on the surface, it binds to this surface receptor. And you can see a small thing which says that ACE2, which is an enzyme which is there in humans, in mammals, angiotensin converting enzyme 2. And it is this receptor to which the spike of the SARS-CoV-2 attaches. And once it attaches, it then magically opens the epithelial cell. And there is an envelope created of the epithelial cell around the virus, which initially protects it from the effect of the host immune response. Once within the cell, there is release of the viral genome, which is the RNA. This RNA enters the endoplasmic reticulum, and it uses the host replicative mechanism for forming proteins to replicate itself. And then it creates copies of itself. Once those copies are created, the copies then use again the endoplasmic reticulum to translate the viral structural proteins that are required, which include again the spike, the envelope, and the membrane proteins. So all these combine with the nuclear material and give rise to new virus particles. And these virus particles then are enveloped by a vesicle, which the viruses create in order to protect them from the host immune response again. And then through a process of exocytosis, they exit the cell. Now, when they exit the cell, usually they will have an effect on the cell, which is described as cytopathic. So it will result in the cell becoming ill, and many times it will undergo a process which occurs with senescence or with death, what is described as apoptosis. Now, this apoptosis, programmed cell death, happens slowly over a period of time, many years sometimes. But if this process does not occur, or it occurs very fast, then it may be described as pyroptosis. And this fast process may result in stimulating our immune response in ways that produce disease. So one aspect is the cell death which occurs because of the viruses using our cellular machinery. And the other aspect is how the viruses will result in an immune response, which may sometimes go awry. So that's how the SARS-CoV-2 virus enters the cell, uses our cellular machinery, replicates, forms new small particles of itself. And then, from being on the edge of life and being almost non-living becomes living. And like all life, replicates itself. And also, there is this question of the fittest, of survival of the fittest. But I want to tell you that survival of the fittest may be only one truth. The other truth may be that while in the context of single cells or single organisms, it may be survival of the fittest. So finally, viruses, bacteria will need to cooperate and coexist in order for life to exist in all its beauty. Now, what disease does the SARS-CoV-2 cause? So again, the SARS-CoV-2 disease causes this disease COVID-19, which was coined in January 2020. So coronavirus disease. So it's a very simple way. And since it started in December 2019, it is described as COVID-19. Now, the COVID-19 disease is a viral disease. And the way this disease occurs is through these bubbles at the bottom of this slide. I hope you're able to see the slide. So you can see that the first bubble describes how the coronavirus enters, replicates, and then gets released and has a cytopathic effect. The second part is how it stimulates the immune system. Now, our immune system, I'm going to have to take you a bit back to 12th standard biology. So our immune system, the white blood cells or white blood corpuscles in our body are of two or many types, but primarily of two types. You can describe them as neutrophils and lymphocytes. Okay, so among the neutrophils, they usually help us combat bacterial infection or larger antigenic particles. The immune response to viruses is generally mediated by lymphocytes and other white blood cells, which are described as macrophages or monocytes. So what happens is these virus particles, when they interact with the host cell, at that time, if that particular person has T cells are a type of lymphocyte, has T cells which recognize these antigens, then quickly those antigens are identified and the T cells will have an effect on those cells and quickly kill those cells off. So if the cells are killed, then the viruses cannot replicate within those cells. And that would be the innate or pre-existing immunity which is there in our body. And like I told you, the coronaviruses are a large family. And there are T cells in our body which may be able to recognize these viruses and mount an immune response quickly so as to limit their cytopathic effect. And of course, in effect, when those cells are destroyed, the virus particles are also destroyed. And the antigens that are related to these virus particles, they will be presented to the immune system, which then further will lead to a process called cellular immunity, where T cells of different kinds will get stimulated and they will form memory of these virus particles, which will then be stored in our body. The T cells will then stimulate our B cells or B lymphocytes. And these B lymphocytes will produce antibodies. And these antibodies will be of different types. And the production of antibodies will protect us against future infections or further infections that may be caused by the corona SARS CoV2 or other viruses. So this is the process broadly by which our immune system interacts with the SARS CoV2. Now, supposing we don't have those effector T cells which can recognize the virus particles at the beginning, then these viruses can multiply, use the host cell machinery, have a cytopathic effect, break down these cells. This process also will produce an immune response, but this will be a naive immune response and it may sometimes be excessive. And the number of mediators or cytokines that are produced by this cytopathic effect, they produce what is described as inflammation. Inflammation typically is swelling of the body cells and tissues because of these chemicals called cytokines. And these cytokines can have a beneficial effect as well because they will help us to control the cytopathic effect of viruses and help to kill off the viruses. But on the other hand, they may affect the normal body cells as well. And typically in the SARS CoV2 infection or COVID-19, these cytokines that are formed, they have an effect on the lungs. And the effect on the lungs is partly the cytopathic effect of the viruses. So starting in the nasal epithelial cells, then proceeding along the airways, going to the alveolar epithelial cells, infecting them, causing cytopathic effects there, producing these inflammatory mediators, and then producing swelling in the lungs. That leads to the need for oxygen. So that, in a nutshell, is how COVID-19 causes its disease. Now, a little bit about how the disease progresses and how it starts. So typically, the disease has 5 phases, and the 5 phases are on this x-axis. You can see this, the time is depicted in days. So typically the incubation period is up to 5 days, but the incubation period may sometimes last up to 14 days. So in this figure, I've taken the incubation period as 5 days. So the virus enters. So that's the tip of the diamond at the left side of the figure, the blue diamond. And then the virus begins to multiply. And it is typically on day 5 or so that symptoms will begin to happen. And these symptoms will be mild fever, cough, body ache, sometimes diarrhea may be there. And then typically, loss of smell has been described as an early finding. And these symptoms are sufficiently non-specific for us not to be able to recognize it. So in this early period, the pre-symptomatic period, you can see that the viral replication has already started. In fact, the viral replication has reached a maximum, the center of that diamond, on day 7 or day 8. And so the virus has multiplied and is being produced in large numbers already at times when the symptoms are minimal or when the patient is pre-symptomatic. And so you cough or sneeze or you speak and you don't maintain social distance, then the infection is likely to spread. And typically, viruses are described as causing infection. So if one person can infect 2 people, that's called an RR of 2. And the SARS CoV2 virus has a high reproduction number, or its ability to spread because of this early pre-symptomatic symptomatic phase when viral replication is at its maximum and maximum viruses are produced. That confers the ability for the virus to be highly infectious. So it's not a very dangerous virus in that sense, but it can spread like wildfire. And it is partly because of this that it has spread so rapidly around the world. And of course, the fact that it is a novel coronavirus. This virus was not there before. It made its jump from the bats. And typically, in China, the Wuhan seafood market was described. And it is proposed that from bats to pangolins, maybe, the anteaters, and then to humans. Of course, conspiracy theorists believe that this may not be true and that this virus may have been engineered in a research lab in Wuhan, one of their premier research laboratories for viruses, which is located in Wuhan. And the synthetic virus was being researched on, and it accidentally was let loose. And so there are a substantial number of people believe that this may be a synthetic virus and that it may not have made this normal jump. Of course, that debate is still on, at least for the time being, that it is a natural virus and that it has made the jump from bats to pangolins to humans is the theory that is doing the rounds. Anyways, coming back to the virus and the pre-symptomatic and symptomatic phase, which confers its great infectivity. The mild symptoms appear, and these are primarily due to the cytopathic effect of the virus. Then our intrinsic immunity kicks in. We begin to destroy some virus particles. The virus gets presented to our immune system. And as the immune cell system gets stimulated, if this immune response is dysregulated, and we don't know how this gets dysregulated. In fact, this is one of the areas where we are really running blind. It's like Pandora's box. We don't know how the immune system really operates, especially in these early stages. If it goes awry and it gets dysregulated, then it may produce immune damage. And like I described to you, cytokines are produced, which then begin to cause the need for oxygen because of the swelling in the lungs. And then as this swelling in the lungs progresses, there may also be stimulation of the clotting system in the body, what is described as thrombophilia. And both together, clotting abnormalities and the immune destruction result in what is described as a late pulmonary phase, which starts from day 14 and may persist up to day 28 or so. And now, of course, there is also a post-COVID or a long COVID syndrome, which has been described. And the virus, unlike the previous coronaviruses or the previous pandemics or the flu pandemics, seems to be here with us to stay. And it is producing an illness which is not just acute and disappears. In the sense, in some or most people, it will be mild and it will go away. That is true of the COVID-19 or the SARS CoV2 virus. So 80% of people will be only mildly affected. And the remaining 15 or 20% may be affected severely, but there will be a small percentage, maybe around 3 to 5% of people who may develop a longer disease process because of COVID-19. And because the virus is new, it may not immediately go away. So that going away or the ending of this pandemic may depend to a certain extent on vaccines that we are able to develop. A brief look now at the treatment that we have for this COVID-19 illness. I'm sure all of you are familiar with this drug called remdesivir. You know that the Gilead stocks, they went sky high when the paper in the New England Journal of Medicine was published, which said that there is improvement with remdesivir, that it reduces the viral load and it improves the number of days. So if you were to recover in 11 days without taking remdesivir, you will recover in 9 days. But unfortunately, it did not show that it prevents progression to serious disease or decreases the mortality. Yet, because there was no other drug and there is no other known treatment for it, remdesivir received emergency authorization, both in the US and then in India as well. Initially, it was short, but now the drug is available and it is being used extensively for patients in the early phase of illness. When they begin to require oxygen, that's the time when remdesivir will have its best effect. Late, when you can see the viral replication has gone down, it will not have much effect. Then we have steroids. I'm sure you all are familiar with the term steroids. Steroids are anti-inflammatory, immunosuppressive. They suppress our immunity. They are drugs which are double-edged. So on the one hand, by suppressing this dysregulated immune response, which may have gone awry, they help the COVID-19 disease. And now there is very good evidence. There is a large trial which was published in the Lancet. So that's another thing, the speed with which some of these studies have been done
Shiva, we are losing you. The signal is, I think,
statistics and clinicians and get together all that data together and quickly processing it, information technology. So the steroids and remdesivir are products of this world. And it is seldom that so fast in a disease, treatment has been identified and put into practice. So steroids, the drug is dexamethasone, and they have a salutary effect, but we have to watch out because they have side effects like increasing the blood sugar or suppressing the immunity and causing secondary infections. Then the next drug is heparin, which is an anti-clotting drug. So it prevents blood from clotting. Now, what we've realized is that COVID-19, unlike other viral illnesses, it affects the clotting system and it tends to cause clotting within the blood vessels of the body. Clotting usually occurs when the blood vessel is breached. So in order to prevent loss of blood, the blood vessels repair themselves and a clot forms which stops the bleeding from occurring. But this process of clotting occurs within the blood vessels. And to prevent this, we use this drug called heparin. And steroids and heparin together, one may say, are the mainstay of treatment at the moment. Remdesivir, yes, but it's a smaller part. So steroids, heparin are the mainstay with remdesivir. Then we have this drug called tocilizumab. If you have been following the news on COVID-19, it's a drug, expensive drug, which is produced by a company called Roche. And there was a trial reported by the Roche company to sponsor drug. And the trial, unfortunately, was negative. Negative meaning the drug was not shown to have an effect on mortality, but it was shown to be safe. So this is again an immunosuppressive drug. It acts on a particular inhibitor. It acts on a particular mediator called interleukin 6. It's an interleukin 6 inhibitor. And opinion is divided. Some people feel that it's a magical drug, which sometimes can produce magical results, but equally it may produce, because of its immunosuppressive effect, it may produce secondary bacterial and fungal infections, which may kill. Then, we have the treatment for the extreme air hunger that develops in COVID-19 because of affection of the lung. So in order to explain it to group, I spoke to Pankaj. He told me that you're going to be dealing with primarily a group of engineers. So they may not have had any exposure to biology after their 12th standard, except of course, he told me that there is a pediatrician and there is some active research which has been done by your group on maternal and child health. So in order to describe what happens in the lungs, I think lack of oxygen is what happens. And lack of oxygen in the lungs is not tolerated very well by humans. It is very similar, the lack of oxygen which occurs is very similar to what happens when we go on to the high altitude. So some of you may have, been to the Himalayas or to heights, and you know that if you suddenly go to a height where the atmospheric concentration of oxygen is low and it results in lack of oxygen, that can produce breathing difficulty and may cause what is called high altitude pulmonary edema. Now, the pulmonary edema that occurs in COVID-19 is similar in its effects, not in its mechanism. So in COVID-19, what has happened is the alveoli have been filled with fluid, which is partly because of the cytopathic effect of virus and partly because of the inflammation or swelling of the lungs. And these together result in air coming up to the alveoli, but oxygen not being able to be exchanged with the blood vessels. So it cannot enter what we describe as the alveolar capillary membrane and go to the blood vessels. So the blood vessels are then starved of oxygen and the body then is starved of oxygen. And this starving of oxygen is what results in the breathlessness and eventually kills in COVID-19. And for this, then the only mechanism we have is to use higher and higher concentrations of oxygen. And oxygen is a drug. If used in higher concentrations, it can have toxicity of its own accord. And oxygen toxicity is well described. In fact, oxygen has evolved much later in our world, and the earlier organisms did not really use oxygen. And this oxygen, because it can affect cells, which may be, partly built because of help with viruses and bacteria, there may be toxicity on the cells by the production of oxygen free radicals, which can also contribute in later stages to worsening of patients with COVID-19. Then we have HFNC NIV. HFNC is high flow nasal cannula. So the ability to give 100% oxygen comes with high flow nasal cannula, and then non-invasive ventilation. So ventilation or breathing support with the help of a mask, and ventilation, of course, you put a tube in through the trachea and then you push air directly into the lungs. But like I told you, the problem is not in being able to take in air. It is not being able to exchange oxygen. And that can only improve if the disease process improves. So at best, oxygen, HFNC, and IV ventilation are all supportive therapies. Okay, so that's the COVID-19 disease, the SARS CoV2. So I'm at a point where we can take a small break and I can allow some questions.
Shiva, this is Pankaj.
Yes, Pankaj.
And so I'm also going to look at that. It's very fascinating, but we looking at time.
Yes.
if you can also...
Are we now 30 minutes or so?
Sorry, I was going to say, suggest another 10-15 minutes. And
yeah, okay.
So then we have time also for questions. So if you
okay.
can also share some of your, the
I've taken a bit of time with this because, understanding what the viruses and the disease process was important. The rest will be a little easier to understand and will go a little faster.
Yes, also the experiences,
yes,
which are the other aspects of the medicine and all that.
Yes.
Can I request that you go ahead and share with us all that, and then we can open it up for questions? Or you?
Sure, of course.
Within
of course,
we it all together, and also we'll be able to manage time.
Sure.
Yeah, thank you.
Sure. Okay. So, I'm going to make a small point about the fear which is caused by the case fatality rate and the number of deaths that we see and the number of cases that are getting infected. So, I must remind you that the number of asymptomatic or pre-symptomatic individuals is much larger, and they represent what is below the tip of the iceberg. The severe cases or the deaths which occur are a small number of cases. And so if you were to think of infection fatality rate, or if you were to think of mortality rate which looks at the population and the number of deaths which occur because of COVID-19, the numbers will go down and the mortality rate will probably settle down to less than 0.5%. But now, when you're in the throes of this pandemic, it seems to be very frightening. Okay, then I've told you about this, how COVID-19 can spread. And these are the various groups of people who can spread it and why it is so highly infectious. Then I've told you about the immunity that develops. So SARS CoV2 infection, in the vast majority, after a mild viral respiratory illness, will result in the development of immunity. We are only beginning to understand now the kind of immunity that it will produce. So hopefully vaccines will be there, which will be able to stimulate this immune process without actually causing the SARS CoV2 infection. But we are a bit far away from that. It may take another year or so for vaccines to come in. Okay, so I'm going to skip some of these slides about the immunity. Okay, so a quote from Louis Pasteur, the father of bacteriology and the infectious disease hypothesis, that one organism, one disease. So on his deathbed, apparently, Louis Pasteur said that Bernard, another physiologist of his time, was correct, and that he was wrong, that the microbe or the germ is nothing. The terrain or the milieu is everything. And it is only now that we are beginning to understand how complex the terrain is. Then for those who like to read and would like to expand their view, this book is highly recommended, and by Ed Yong, called I Contain Multitudes. Okay, so those are the slides that I have. And now I'm going to talk to you about our experience with COVID-19 in the next 10 or 15 minutes. When we had the first case in our hospital, it was 17th of March. And the lady came in with being ill for the last 7 or 8 days. We already were aware that at some point we are going to experience or encounter patients with the COVID-19 disease. And so she came with a respiratory illness, and she was breathless when she came in. Her lungs showed typical shadows, which would have indicated COVID-19 disease. And we sent her test to the National Institute of Virology, which had already started doing the tests somewhere end of February, beginning of March. And there were already cases identified in Pune, in Thiruvananthapuram, and in some other places in India. So the first serious case, she came to us on 17th of March, and she was arguably the first serious case which we encountered in Pune. So this lady rapidly progressed in her breathing difficulty and went on to require non-invasive ventilation and ventilation. At that time, the hospital was not prepared. I mean, we did not have the infection control precautions that are necessary to prevent the spread of SARS CoV2 and COVID-19 within the hospital. And so naturally, there was a lot of panic. The disease had already begun to affect. We already knew about the China Wuhan epidemic and the roughly 3.5% mortality rate. And we were looking at Italy and Spain and the UK having very high case fatality rates and rapidly people developing the disease and succumbing. We also had, the Italian Prime Minister coming out onto the street and saying, "Yeah, I give up." So a dramatic response to the way the COVID-19 pandemic overwhelmed healthcare systems around the world. And so that fear was there within our minds, within the nurses' minds. Of course, of being overwhelmed was one fear. The other fear was being personally infected and suffering from a disease for which there may be no comeback. And so then, we got together personal protective equipment, those astronaut suits that are so commonly seen in initial pictures of the pandemic. And I think the public image is still of those personal protective equipment that resemble astronaut suits. And so then in that time, from the 17th of March till about the 1st or 2nd of April, she stayed in the hospital for about 17 days. She was very ill. And in fact, there was a time when we thought that she may not recover only with mechanical ventilation, that she may require extracorporeal membrane oxygenation. So where you take the blood out and oxygenate it and send it back to the body. Fortunately, she did not recover that, and she did recover. And she recovered mostly on her own. And some of the drugs that we used at that time were, drugs which were recommended at that time, which later now are not in our armamentarium any longer. So there was a anti-AIDS HIV drug, lopinavir, ritonavir, which went out at that time. And now, of course, we have remdesivir. So she recovered. And in that period, we had time. We did not have any more cases, fortunately, at that time. The pandemic was still at its beginning in Pune. And this case arguably also was the first case of community transmission which occurred. Because come what may, we could not identify whether there was some contact from abroad who may have passed the infection on to her. So it was a completely homegrown thing in that sense, where we could not identify. So it was local or community transmission within country. And that was frightening because it meant that it would quickly spread and we would soon see a peak of the pandemic. So then the preparation, it meant having to create a section within the hospital, which could be segregated from the other hospital. So in a sense, create a COVID hospital and to create a non-COVID hospital. So we could roughly demarcate about 150 beds, create a separate entrance, write down the protocols required, create the necessary infrastructure to segregate and seclude that part of the hospital from the rest of the hospital. Then look at the human resources, divide the human resources into people who would work in the non-COVID area and then in the COVID area. So, distributing it equally. And then, of course, there was the described period of quarantine at that time. So those people who worked in the COVID area could not directly go back and work in the non-COVID area because the risk of spreading it to the non-COVID area of the hospital would be there, and quarantining them because they may spread it in the community. So all that was there at that time. And we went through that period, March, April, May, and we were waiting that the numbers will increase tremendously and we will reach a peak and our capacities will be overwhelmed. Fortunately, that was the period when the lockdown also was there. And the lockdown probably helped us to slow down the spread. And that slowing down was useful because it helped us to prepare hospitals. The administration had some chance to put in place preventive measures, to create enough public awareness, and to create protocols and guidelines for management. I think in that sense, our country has functioned much better in this pandemic than it did in the swine flu epidemic. So then May, June, July, these months, the cases kept on increasing gradually. The municipal authorities, they were behind us. They said that the number of beds are not adequate. We need to create more beds. And they had this figure. I can pull it out if I can, just to show how the number of cases were increasing. And the projected number of ICU beds and ventilators that would be required as projected for July, actually, initially, would exceed the capacity of ICU beds and ventilators that were available in Pune. And this would be true, in a sense, not just in Pune, but all over the country. Now, Pune has certain unique properties as a city. It has the National Institute of Virology, so it allows us to do extensive testing. It has a very aware and cosmopolitan populace, which understands and does participate well in infection prevention. But equally, the city has, is bursting at its seams. The population has grown tremendously. Overcrowding is rampant. And in this initial part, in these May, June, July months, we were seeing patients more from the lower socioeconomic strata, where overcrowding was prevalent, maybe malnutrition was prevalent. And also, from communities where practices would not allow social distancing very well. That phase, of course, has given way to now what we are seeing from mid-July onwards and in August, that it is predominantly the middle and the upper middle class which is getting affected. Along with them, the lower socioeconomic strata are also affected. And we've reached a point where getting hospital beds in Pune is virtually impossible. Especially hospital beds where oxygen can be given is becoming a problem. And then, of course, I'm sure you've been reading about the oxygen crisis. So the amount of oxygen that is now required is beginning to reach the limit of what capacity oxygen can be produced, both in Pune and, of course, in our country as well. So much so that the industrial oxygen now has been diverted for being used for medical purposes. And new plants, the authorities are looking at setting up and producing more oxygen. So oxygen is another challenge. And then along with this, Pune, like all the other cities, and this rural-urban migration that we are so familiar with, has a number of people working in Pune who go and stay in the rural parts surrounding Pune. And that has resulted in the spread to those areas. And now those areas are getting affected and getting serious cases. Those places have no health infrastructure really to speak of. And so those cases, apart from the less ill ones, they cannot be managed too well. And so they also tend to come to larger cities. The capacity building that has occurred has been in the form of, getting more ventilators, creating oxygen capacity, having more oxygen cylinders, equipping rural hospitals, primary health centers with oxygen. Now, the oxygen lines being created, cylinder banks being created, the ability to transport oxygen from the plants to rural areas, that is being ramped up. So all these are things which are in development and are happening quite rapidly. So these are some of the things which are happening within the epidemic. And the capacity to manage patients who require oxygen or sick patients, that kind of expertise does not exist with medical officers and nurses working in primary health centers or in rural hospitals. So our hospital, our medical college has been part of an initiative along with the Director General of Health Services, Dr. Archana Patil. We've created a module and we teach this on Zoom. We've created some videos on how to use oxygen, how to conserve oxygen, how to use ventilators, and how to rationalize the treatment for COVID-19. What would be the appropriate time to start treatment? So all these things have happened simultaneously. A last thing that I would like to touch upon before we can take questions would be, the human factor and the way this pandemic epidemic has affected the doctor-patient relationship and has affected relationships among us. The social distancing and the closing down of theaters and malls and schools has meant that children, adolescents, adults, we're all very social animals. It has meant that we have had to curb our natural social instincts and have had to interact more just through the virtual media. And that has imposed a great strain. And I fear that it will really change things. Touch, for example, I mean, it has practically gone away from the medical examination. Most of it is driven by tests and by monitors. And this aspect is something which is going to deeply affect all of us, I think. In addition, families, near and dear ones, are infected, they get admitted in hospital, especially older people. The moment they are admitted in hospital, they have to be isolated from the rest. So, people who are frail, old, they have to stay alone in general wards, away from their family, so nobody to help them. And there will be just one nurse looking after, maybe in good places, maybe 5 or 10 patients, but where capacities are overwhelmed, there may be one nurse looking after 20, 25 patients. And that, in effect, means that you really cannot provide the tender loving care that is required. And the human interaction, that human to human interaction, is lost. The only way families can interact is through WhatsApp calling or video calling. And I think that is also going to be a social impact of which I cannot begin to see the ramifications. And then, of course, the economies have been affected, migration. There are all these factors, but I think we will tackle those as we go along through questions. Pankaj, I think I've touched upon most of the things that I wanted to touch on. Anything that you feel I've left out, or anything more that you want me to?
No, fantastic. Thank you so much. If you can stop sharing your screen, then we can see you full screen.
Sure.
I will.
So
Abhinav and Sudha kind of help moderate, and I think we can take the questions now. So thank you so much. That was very fascinating. Sure. Priya, if you want to say something, and then Abhinav and Sudha.
No, that please go ahead. Abhinav and Sudha, continue with the Q&A.
Okay. So we can have the Q&A session. Participants can raise their hand or put your questions on the chat section. Also, we have some viewers on YouTube watching live, so even they can put their questions on the comment section and we'll read it out for you. Teresa, you can ask your question.
I have a request. So the person who's asking the question, I would like them to, identify themselves, say a little bit about their background. Yes, Teresa.
Yeah, hello, sir. I am an MTech student here at Sitara.
Okay.
So in the talk, you mentioned that it will take a year or more for the vaccine to come.
Yes.
But we see that there are vaccines which are at the clinical trials, and they claim to come after December or something like that.
Yes.
So
yes.
I mean, how so why do you suspect that it will take a longer time?
So,
the second part is
okay.
The second part of the question is if we take a year or so, are there any mutations that can be expected? Will the virus change, and would that create a problem?
Okay. So the first part of the question is that when the vaccines, typically before the SARS CoV2 and the COVID-19 pandemic, used to typically take at least 3 to 6 years. That was the usual period for vaccine development. And there are a couple of diseases. For example, there is the HIV, AIDS virus, and then of course we have the dengue virus, 2 common viruses, and infecting a large populace. We still don't have a vaccine for it. Research on it has gone on for the last 20 years or so, and we still don't have a good vaccine. So some trials have happened, but none of them have really entered clinical practice. So vaccines typically take a long time to be developed and then come into clinical practice. And vaccines, like other therapeutic things, they usually go through what are called phase 1 and phase 2 and phase 3 studies. So phase 1 studies are where you study the safety of the vaccine, maybe using an animal model. Then there are phase 2 studies, which are done in smaller groups of individuals. And then phase 3 are the large randomized clinical trials that are done in order to, study the effect of the vaccine on a larger population. So when, fear predominates, and there is the fear of this pandemic, and we feel, we want some magical bullet or something which will, cure us. Of course, you're right in saying that, the politicians, Trump and our honorable Prime Minister as well, they have made announcements that vaccine will be available in the next 2 months. By November, December, we'll have vaccines. But I'd like to remind you that, the first vaccine which was being trialed, the Oxford COVID-19 vaccine, the trials have been halted. The phase 2 trials which were being conducted have been halted temporarily because someone had a side effect. In India, the trial has not yet started. Or if it has started in a very small way and has now been suspended. So the trial will be done, then it will be published. So the earliest I can think of, in case, and you're assuming that the vaccine trial is going to go in a positive way, that there will be no. So that I think makes for bad science, because then you don't have equipoise when you're starting doing some trial. So trial typically is when you believe equally in both possibilities, that it may work, it may not work. So, and when there is bias of this degree, and of course there is the influence of industry as well, then things may be introduced in haste, which, at best may not work, and at worst may cause side effects which we may not imagine. So these are all apprehensions in my mind, and I hope, like you hope, that the vaccine will come earlier than before. The second part of the question was whether the virus will mutate. So typically, these respiratory viruses, the coronaviruses and the influenza virus for that matter, the influenza virus is a DNA virus, by the way, and this is an RNA virus. So they do go through a process of mutation, and it's finally survival of the fittest, isn't it? So the virus doesn't want to be eliminated. It wants to be within the host, multiply, and if possible, cause infection that will be milder, and which will enable survival of both the virus and the host. If the host gets killed off and all of us die, then the virus also will die, isn't it? So that's where I say that, it is not so much about fittest, survival of the fittest, but it's also about arriving at a balance and coexisting. And that process will be helped by vaccines, but it will also be helped by natural infection. So while the number of deaths which will occur because of COVID-19 will be there, my hope is that we will achieve natural immunity, what is described as herd immunity. A certain number of people will get infected, and that will raise immune levels in the community to a level where the coronavirus disease becomes milder, and we will coexist with this coronavirus as we have learned to exist or coexist with previous viruses. The mutations will be a challenge for vaccine development, but then, the influenza virus, every year they produce a vaccine. And so it is possible that for the SARS CoV2 or the COVID-19 disease also, we'll need to produce viruses annually, vaccines annually, but that is in the future yet. So 6 months at least, if not 1 year.
Thank you, sir.
Teresa, you want to ask a supplementary?
No. I was just telling thank you, sir.
Okay, yeah.
Okay, now we have a question on the chat by Professor Narendra Shah, sir. And he asks that what is your scholarly opinion on the big question of when this would dilute, if not vanishes completely?
Very, very, very difficult to say. In fact, my feeling is that it will continue. It will continue for a year at least. And in India, as in other smaller countries like in Italy or Spain or the UK, which are fairly homogeneous countries with good healthcare systems. They had a peak and then the number of cases went down. And now, you see the number of cases which are reported daily or the number of deaths which occur have stabilized at a very low level, which is easily manageable. So in India, you see it is the 5 major cities. There are 5 or 6 major cities that have contributed the maximum number of cases at the moment. And so these cities will reach a peak and then they will begin to come down in the number of cases that are going to occur in those cities. But unfortunately in India, healthcare is concentrated in these cities. So other places don't have good healthcare. And so as the other places reach their peak, those cases will then come to the city. And what I see is that, there will be a conglomeration of peaks. And larger cities will peak earlier, smaller ones, places with less dense population will peak later. And this process in a large and diverse country like ours is likely to continue for at least 1 year. And herd immunity is actually conceptual in that sense, because it's not that magically the herd is conferred with community. It is the number of people who get infected within the herd. So if we look at the New York City as an example, they did a seroprevalence study where they looked at the number of antibodies in a small sample of their population. They found about 20% people tested positive for the antibodies. And typically for herd immunity to develop, it takes about 50 to 60% of the populace to be affected. And I kind of shudder to think, if we say that larger number of people get, now India has about 500 crore, 50 lakhs people infected at the moment, and we have about 80,000 deaths. So if I were to double this and say 1 crore people, and so it will become 1,60,000. If I say 10 crores, then it will become 16 lakhs. And then say 20 crores. So I'm looking at, if the herd immunity is going to be reached, we are going to see a large number of people and a mortality which is going to be unprecedented because of if herd immunity is to be developed. And I'm not very optimistic about the vaccine coming in time to be able to prevent these large number of deaths. It does not still mean that as individuals we should panic, because like I said, among 100 people, only about 20% of people will develop severe disease. And of that 20% which require hospitalization, only about 5% will end up in the ICU. And an even smaller number of those will die. And those will generally be deaths which occur in older people and people with comorbid diseases. So we should not worry too much, but it is going to be overwhelming as far as our healthcare system goes, our economy goes. So those are all larger and bigger problems that are going to occur because of the virus. And so to Sir Dr. Narendra Shah, Professor Shah, I will say that it will take at least a year before it dilutes.
Sir, he has also added a
supplementary
question. Yeah.
Yes. So why is the spread less in China or in Thailand? I don't have easy answers to these questions, but one aspect is that in the East Asian countries, unlike India or the Southeast Asian countries, the healthcare systems are better developed. Look at Japan. Even Japan has very few cases. Partly, the use of masks is really widespread, and they are not as social a people as we are. And social distancing, the use of masks, acts like a vaccine. In fact, a study in the New England Journal of Medicine has proposed that masks may work like vaccine. So a process called variolation. In fact, I had a slide in my presentation. I did not show it to you. So if you are able to reduce the number of particles that are likely to spread when we cough or sneeze or speak, then a milder infection will be produced, and that will elicit an immune response, much like a process called variolation, as opposed to vaccination, variolation where, small quantities of the virus could be introduced, which will produce a protective response. So masks, in essence, will produce variolation. And this process, I think, is on in some of the East Asian countries. Not that they will not have second peaks, because they have not achieved herd immunity. So the seroprevalence there is quite low. And as time goes, the seroprevalence is likely to increase. And as the number of people infected increases, we will see a second peak or second surges in these countries as well. The other aspect could be our genetics and the way our genetics interacts with our immunity. So it is possible that there may be certain genetic makeups which are inherently protective and tend to cause milder infection than other genetic makeups. So that's another possibility. So I think these are the two reasons why I would say that the spread or the number of deaths is not as much in some of the East Asian countries.
Thank you, sir. So we have a question from the YouTube live session.
Okay.
So we have Deepak Sharma. He is a BTech mechanical engineer and is currently pursuing MTech at Sitara. So
Okay.
he would like to know your comments on the plasma therapy that is being used right now
Okay.
as a part of the solution, and how has it been used before?
Okay. So, plasma therapy is described as convalescent plasma. So if you remember, I described how our immune system combats microbial infections. So the stage where memory T cells are formed and they stimulate the B lymphocytes to produce antibodies. Those antibodies are then circulating in the blood and they remain at high levels for at least 3 to 4 months. So these high levels of antibodies, they are described as neutralizing antibodies. So these high levels of antibodies, they can prevent entry of the coronavirus into the body, into the human body. And so these antibodies are a process called passive immunization. Vaccines are active immunization because they stimulate the body's immunity and produce it. Passive immunization is where antibodies are directly transfused. And so these antibodies may help to prevent the viruses from entering the cells of the body itself and thereby preventing the infection. So, as a corollary, it would mean that convalescent plasma would need to be given fairly early in the course of the disease. Unfortunately, giving it very early is at a time when many people, like I told you, 80% people will have asymptomatic infection, they'll recover on their own. You'll be giving it at a time when most people are going to recover on their own. So would it be overkill, giving it very early? And then if you were to give it later, you may prevent viral replication at that stage, or you may prevent the viruses from entering new cells. But by that time, the damage has probably already been done. So convalescent plasma, there is a large Indian multi-center trial which has been recently reported called the PLACID trial, which in patients with moderate COVID-19 disease, when oxygen requirement has started, but it has not gone on to become very severe and patients have gone on ventilators. So when oxygen requirement has started, convalescent plasma was given to these people. And unfortunately, there was no difference between the experimental group and the control group. And so it was not shown to work in a large multi-center randomized trial run in India. Apart from that, there are observational studies which show some benefit in foreign countries. There are smaller randomized trials which have been done in other countries which show some benefit, but have not really shown the benefit to reduce mortality or preventing progression of disease. And probably because we've not been able to use it very early. But then again, the question arises, if you use it early, is it overkill? Has it been tried before? So convalescent plasma has been tried before in the swine flu pandemic. It has been tried in Ebola, in Nipah, in the SARS and the MERS epidemics. And really in none of these, it has been shown to conclusively be of great benefit. And so at the moment, I'm not a great believer in convalescent plasma. So we are not using it at our at our hospital. I hope that answers the question.
Yes, sir. Now we have Arshi. Arshi, you can unmute yourself.
Hello, sir.
Yes.
First of all, sir, thank you for the very informative presentation. Sir, I had a question regarding the revised ICMR policy for the revised discharge policy.
Okay.
And so it says that we can discharge a person in after around about 10 to 15 days if there's no symptoms and
Yes.
there's no need for prior testing.
Yes.
So, sir, I had two questions regarding this. Then, sir, how do we establish that whether the patient is cured or not? And secondly, sir, is there a risk of transmission from such patients who have not been tested negative but have been discharged?
Right, right. So, if you remember the slide I showed you about the clinical course, where the viral replication is maximum up to day 14. And after that, the viral replication goes down markedly. And what we have found is that in the about 14 days or later, the test that we do for detecting the virus, it's called the RT-PCR test, which detects the RNA of the virus. So it doesn't detect a whole virus. Yeah. So what it detects is the RNA of the virus. And, it may be equally a dead virus. So the question of transmissibility after 14 days is practically nil. Yeah. The transmissibility, like I told you, is maximum when the dose of virus that is being transmitted through a droplet, through coughing, sneezing, or speaking, has to be large. If it is a small, then the infectivity of that person is very low. Yeah. So that is one aspect of the question. The second aspect of the question you've asked is that, is the patient cured? How are we releasing him into the community without knowing whether he's cured? So for all practical purposes, if he has no fever, if he has no oxygen requirement, then he is considered to be cured. After he is discharged, usually now the revised ICMR recommendation is that you can discharge a person on 10 days. At 10 days, he's advised home quarantine for the next 7 days. Now, the reason for this revision is partly because of our understanding of science and that the person is less likely to be infective at this stage, and that he has less chances of developing a relapse or recurrence, which is very minuscule. The numbers there have been a couple of cases which have been described, but they are very small. And so that's the reason why the ICMR guideline has revised. The other thing is, hospital beds are overwhelmed. Now, just as an example, when we started, we had, like was pointed out in the introduction, we have 300 beds. So of the 300 beds, about 100 beds or so were where we had asymptomatic patients for isolation. Okay. Now, all the 300 beds are oxygen beds. So we no longer have patients who are asymptomatic. In fact, what we do is when patients come in to the hospital with a positive test, we judge whether they are going to be home isolated or not, and we send them home. And the reason for this is that the large, very acute hospital, if you keep people in the hospital, the bed is more serious. So these are the two reasons why the ICMR policy has been revised.
Thank you, sir. Now we have Hari Prasad. Hari, can you unmute yourself?
Yes, yes. Hello, can you hear me?
Yes, Hari.
Yeah, sir, I am a PhD student at Sitara.
Yes.
I have two questions. One is about, I'm looking at this pandemic from a disaster studies point of view.
Okay.
So in medical profession, actually, when do a medical professional, doctor or any other person says a pandemic or an epidemic as a disaster? And I came across different use like triad and all, like ethical consideration, how a person should be given to oxygen demand and oxygen related supply.
Yes.
So does this change for a health hazard or a health emergency to that of a, for example, plane crash or a train accident? So that is my first question.
Okay.
Second is, every home where COVID patient is there is now a biomedical waste generating place.
Yes.
So how risky is that waste disposal, for example, in a city of Mumbai or in a city of Madras? So how do this waste disposal at each and every home matters? And for example, personally from also from hospitals, how do your hospital in Pune manages the biomedical waste, which is more than normal? I mean, more huge amount.
Okay. Okay. So 2 questions. The first question is about what is an epidemic, what is a pandemic, and when does a pandemic become a disaster?
Yes.
So see, an epidemic is when the number of cases due to that particular disease exceeds the usual number of cases that occur because of that disease. So in that sense, even one case with COVID-19 or SARS CoV2 would be considered an epidemic. But when they occur in large numbers and infect multiple countries, like the SARS CoV2 virus has affected, it would be described as a pandemic. So really, so far, we have had 2 really large pandemics. The first was, of course, the Spanish flu pandemic in 1918. And then, of course, we had the couple of smaller epidemics, which were tending to become pandemics because they affected more than one country, the SARS and the MERS outbreak. And then we had the swine flu pandemic, which affected a large number of countries, but was mild. And then we had the Ebola and Nipah, which were smaller epidemics, did not really become pandemics, fortunately for us. And now we have the COVID-19 pandemic, which has assumed the proportions of a disaster. So if you look at the number of people infected during the swine flu pandemic, the numbers were probably similar. But COVID-19 has come onto a naive population, and the number of people that it is infecting is very large because people don't have any natural, not very much natural immunity to it. And because of that, even though the mortality because of it finally may settle down to less than 1%. 1% of a country which is 1.5 billion, you can imagine, you can do the math. That's going to be a large number of deaths which is going to occur. And when a large number of deaths occur in a health system that is inadequate, you have a disaster in the making. So disaster preparedness, while it is described for both natural and man-made disasters, so earthquakes, floods, droughts, plane crashes, it can also be described for pandemic disasters of this kind, where health systems are completely overwhelmed. That brings me to the supplementary that you asked about disasters and the question of triage and of the ethicality of allocating scarce resources. And what is the ethics of resource allocation in situations like this? So, when resources are scarce, then we need to have a system whereby we can allocate these resources fairly. So a fair system of distribution is what we look at. And there are many such described systems of fair allocation. The simplest kind would be a lottery, tossing a coin. If there's only one ventilator and there are 2 patients, so who will get the ventilator? You can toss a coin. It's fair because either of them can. But then, one person could be a 90-year-old man who's got multiple comorbidities, and the other could be a 25-year-old man who is. So in that sense, then, you would think of the effects of that allocation of resource. So that is called consequentialism, or, there is a Bentham's theory of resource allocation, which says that resources should be allocated in such a way that it produces maximum benefit to the maximum number of people and to the people who are likely to benefit most. And so then you have another system of resource allocation. Now, when healthcare systems are run by the state, then you can implement ethical systems of resource allocation. Unfortunately, in our country, much of the healthcare is private. Yeah, and the government healthcare is primarily geared towards preventive healthcare. Curative healthcare is not what the government is able to do. It has not allocated enough resources to be able to provide curative resources or, to tackle pandemics of such a kind. And so therefore, then it is an unequal system. People who are able to pay, people who are able to encourage or wield their power are able to get beds. Those who can pay get beds. And so it becomes an unequal system. And so therefore, there really is not an equitable allocation of resources. Okay, so that's my answer to your first question. The answer to the second question about biomedical waste disposal is easier. Now in most cities, the biomedical waste disposal has become fairly, structured. And there is a company called POSCO, a private-public partnership in Pune. I can tell you that example, which has partnered with the municipal authority for disposal of this biomedical waste. Now, when the biomedical waste is generated, so that biomedical waste does not infect the people who are concerned, what we do is to use a system of disinfection of that biomedical waste. So we use substance called hypochlorite, so it kills off the coronaviruses, and the people who are going to handle the waste will wear protective equipment, which will prevent them from getting infected. And then, of course, once it is handed over to POSCO, the process of destruction of that waste will be through a process called incineration. Okay, so I think that's how biomedical waste gets disposed, and the risk of spread from biomedical waste is less. Now, if you think of household waste and a large number of pre-symptomatic, asymptomatic people, getting infected, discarding their tissue. Now, if we are to prevent that from spreading, that is where, hand washing comes in and hand hygiene comes in. So, the virus spreads through the respiratory route, through droplets. The other method of spread is through our hands. So, for example, if there is a surface, I'm speaking now, so there is this table in front of me, and on the table, some droplets have fallen. Someone else at home, let us assume that I'm in the pre-symptomatic phase of COVID-19, comes and touches the table. Those coronaviruses then go onto their hand, and then he touches his nose. And so the second mode of spread of the coronavirus is through this contact. And if you have to prevent this contact, I need to be extremely conscious of my hands and where I'm touching, and am I going to touch my face, and then I'm going to use the sanitizer. Or so a combination of cough etiquette, using my hands or my sleeve if I'm going to cough or sneeze, maintaining 3 to 6 feet distance, universal use of masks. These things, along with hand washing, will be able to prevent both droplet and contact. And so the biomedical waste disposal will not be so much of a problem. I hope that answers your question, Hari.
Yes, sir. Yes. Thank you, sir. Yes.
Okay.
Okay, sir. I think we have no more questions now. Okay, sir. So I would like our head of department, Professor Anand Rao, sir, to give the vote of thanks, and we shall conclude by that.
Okay. May I make a comment before?
Sure, sir.
Yeah. So, when Pankaj was telling me about students and about Sitara and about the use of technology in rural areas. So, we really need to develop our healthcare infrastructure, and there are so many areas where I can think of innovation, where engineers and doctors can work together. So, oxygen is one example. So the ability to concentrate oxygen from the atmosphere, the use of oxygen concentrators, of making oxygen more easily available. That is one example. and then, simple designs of masks and how more effective masks can be designed. Then solutions that will help to, so chemical engineers and people like that to, design hand sanitizers and stuff like that. So all these things now would be things, and augmenting the healthcare infrastructure in the rural area is something which I think Sitara is uniquely positioned to think of doing. Thank you. Thank you, Abhinav. I hand it over to you.
Thank you, sir. Anand sir, are you there?
Yeah, I'm here. Pankaj, do you want to say anything?
Yeah, I actually, quite coincidentally, I had raised my hand and I wanted to ask Shiva, and he answered the question that I wanted to ask, is that, what do you think that a place like Sitara, with our students and our focus on technology in rural areas, what is it that, because this world will change so dramatically perhaps, so what is it that, both conceptually and in real terms we might be wanting to do as, within the limited capacities we have? So I think you've
I've partly answered.
Yeah,
the other area could be, in education. I mean, it's going to be mostly online, and how do we promote keeping a distance and yet being close, and how do we improve methods of education? How can we use technology? So all those things are being explored, but I think they need to be explored more.
Yeah, absolutely. Yeah. And maybe we should have a longer conversation on some maybe more specific gaps that, the medical community, whether we can fulfill those gaps, I don't know, but perhaps that. But
yes.
Thank you so much. And Anand, please do the, thanks, Anand. Thanks, Shiva.
So,
thanks.
Yes, Dr. Iyer, I'm really thankful to you for taking out time. I'm sure you must be pressed of time, especially in this kind of a pandemic situation, where all the doctors are in so much in demand. But thanks to Pankaj that you agreed for this talk, and then tried your best to explain all these complicated biological concepts to all of us who are mostly engineers and have been away from the world of biology for such a long time. It was really helpful, and then it is so relevant to know all these things in the current situation that we are passing. So I'm really thankful to you on behalf of all of us. Thanks again, and then maybe whenever time permits, situation allows, you can visit us in Sitara, and then we can see how these collaborations between engineers and doctors can happen. So of course, as we're trying to cope up with this online mode of engagement, it has its own set of externalities on health, I suppose, and especially the eye health. A lot of people are worried in terms of how it is. So that may create another opportunity for medical fraternity to
no, it's the lack of social interaction also, so if I were to do this in person, there would be so much of eye contact and watching of non-verbal behavior as well, picking up cues. So all that is going to, it's going to redefine, the pandemic is going to redefine how social interaction takes place, I think.
Yeah, they keep on calling about this new normal. We are yet to find out what that new normal is going to be.
Yes.
All of us are in search of that new normal. So till we settle down on that, Thank you so much again, and then,
thank you. Thank you, everybody.
Can close.
Thank you.
Pankaj sir, I think Pankaj sir wants to say something.
Oh, sure. Yeah. Pankaj?
No, nothing. That was the old hand that had been raised. So thank you very much to everybody, and of course to Dr. Shivakumar Iyer as well.
Thank you, sir. Thank you, all the faculty and the students for interacting so well. Thank you so much.
Bye-bye.
Bye, Pankaj. Bye.